Good evening, all of you. Welcome you guys. Good evening to all of you. Welcome you all. So I hope all of you are doing great and all. So welcome you guys. Welcome you all. First of all, please do confirm the audio video quality. Am I audible to all of you? Tell me. Audible? Chalo. Let's continue our discussions, all of you. Chalo. Let's start our discussions, everybody. In the last class, we have discussed about the electric field and potential for in case of a volume charges. We have discussed and we did some problems also. Right. Now, ask a session में so we are going to discuss some more topics we are going to see. चलो हम शुरू करेगा. Let's start our discussions, everybody. And before this, we have a great announcement for all of you. So great news to all of you. So we fellows are starting a new batches, you can see, for the GATE 2024. We are starting the new batches for GATE 2024, and you can find the top educators of this is electrical ECE and electrical team. You can find the top educator, the best content you can get. And the new batch is starting from the December 21st onwards. And all of you do enroll for these batches by using the referral code of BV Reddy, and you can get the personalized guidance from me and the best content. I will take care of your preparation for each and everything. So then what you need to do here, and all of you need to subscribe for this by using a code of BV Reddy. Isn't it, all of you? Chalo. Next, and you can see now here. So these are the new batches we are starting for ECE and electrical. You can do follow these batches. From December 21st onwards, we are starting the new batches. And we are starting with the networks. You can see Sundays are starting the networks. Right. And these are the new batches for we are starting exclusively for the GATE as well as also. You can find the top educators team you can find here, and you can find the top educators team you can find here. So all the educators are available here, and these are the new batches. You can see, have a look at here. And so, and one more great news, here. So there is a chance to save 52% off, up to a 52% you will get the chance. So here, if you are planning for this as an Unacademy subscription, so there is a huge price drop you can see. For GATE and ESE के लिए huge price drop is there, so you can utilize it now. You just need to pay this thing as a 27,486 only. You can able to save 52%, more than 50% discount आपको मिलने वाला. And to enroll for this, use a code of BV Reddy. The interested students who are willing for this Unacademy subscription, they can use a code of BV Reddy and join my classes for the personalized discussions. Fine, all of you? Chalo. So these are, we are starting, as you might see the recently this IRMS notifications. Recently you might seen the IRMS notification you might seen. So this is a IRMS batches we are starting. Minute. Able to see the things? Yeah. You able to see this thing? Just a minute. I think some issue. I think some technical issue. Yes. Right. Chalo. Now, yeah, these are new batches we are starting. You can find the top indicators, and so you can save the up to the 52%. You can able to save it now. These are the new IRMS batches we are starting, and you can find the IRMS and CSC mains. ESC mains के लिए we are starting the new batches. You can find the top indicators team. You can find, right, and you can able to save up to the 39%. You can able to save in these new batches. You can plan the subscription as soon as possible, and this offer which is valid only the up to 16th only, 16th December only this offer is valid, right? As I told you now, so here we are conducting this all India mock test, and so this coming Sunday we have a all India mock test is there. All of you do enroll for this mock test as soon as possible, and you can use the invite code of BV Reddy. You can use the invite code of BV Reddy. Chalo. Now let's move the next topic, all of you, last class. And first of all, you tell me now any doubt in the previous classes. You tell me. अगर कोई डाउट हुआ तो पूछो जल्दी फटाफट. चलो, let's move to the next topic, that is electric dipole. Electric dipole. Tell me. And first of all, what is electric dipole is a two charges are equal in magnitude and opposite polarity. Two charges, magnitude of the charges is equal, and the polarity of the charges are opposite polarity, and those two charges, if I separate a small distance, then we can call that as a electric dipole. Then we can call that as called as a electric dipole. Fine. Now consider I have a two charges we have. Consider we have a two charges. We can say this as a one is Q plus Q and minus Q. I have two charges, and the two charges are separated by a small distance are separated. The distance of separation is very small, which is given as what we can say D. If I call the distance of separation is called as a D, then this is called as a dipole. This is called as a dipole. And for in case of a dipoles, we used to define one term that is called as a dipole moment. We'll define the term called dipole moment. Dipole moment, and which will denote with a letter of P. The dipole moment P, which is given as, it is a product of magnitude of the charge into distance of separations. Magnitude of the charge into क्या? What happened? So is it clear? Isn't clear? Is it clear? Not all of you tell me. आपको इस slide अच्छे से दिख रहा कि नहीं बोलो? The dipole moment. Blur? Yes. What of the remaining fellows? Remaining fellows also facing the same thing, or is it fine? Blur now also everybody? Isn't it? Hmm? What are the remaining fellows? Is it clear, or are you facing any difficulty? Let me know so that I'll try to restart something. I think some might be some issue. I think so, maybe. koi nahi means, is it clear to you or not? Fine. Okay. Fine. Is it clear now, everybody? Fine. So see this thing. We can define the term called as a dipole moment. Dipole moment, which is given as product of the charge into the distance of separation. And the dipole moment is a vector quantity. Dipole moment is a vector quantity. And the direction of the dipole moment is from the negative charge to the positive charge. The direction of the dipole moment, so the direction of the dipole moment, which is from where to where? Negative charge to the positive charge, remember. Dipole moment is a vector quantity, the direction is towards the positive charge. Towards the positive charge. Negative से positive होगा, isn't it? The dipole moment is a vector quantity, the direction of the dipole moment is कौन सा direction? Negative to the positive charge. Fine all of you? Right. Done? Now, take one problem. Find the dipole moment. Find the dipole moment. So I have placed the charges are like this. And this is my x-axis and this is my y-axis. Now I place the charge. Here I place one positive charge I have placed now here. Here I place the negative charge I have placed here. Now, so they ask you to find the dipole moment. And this distance is d and this distance also d. Find the dipole moment. The dipole moment is what you tell me now here, the magnitude of the charge into the product of the distance between the two charges. Tell me now dipole moment, if I call this as a p vector, which is given as magnitude of the charge, which is equal to p, and then what else you tell me now here, and product of the distance of separation. Now this is the distance between the two charges now like this. So can you tell me how much the distance here, which is nothing but root 2 into d. So that is nothing but root 2 into d. So here the dipole moment, which is given as what we can say here, this is a charge q now. So what we can say now here, q into, this is q into d. All of you tell me this thing. This is my dipole moment. Everybody? I think so here. This letters also it is not coming properly. Is it clear? आपको कोई दिक्कत है तो बोलिए, so then we'll see. If you have facing any problem, see this thing. कोई दिक्कत है क्या? Then chalo. This is a dipole moment we can find like this. Next. Now let us find the electric field and potential for in case of a electric dipole. Electric field and potential for in case of a electric dipole. See this thing all of you. right. Now let us consider this is my xy plane. In this xy plane I have placed the charges. Let us say here we have a plus q charge is there, and here we have placed a minus q charge, plus q charge and minus q charge, and that these two charges are separated by a small distance. These two charges are separated by distance of d. Now because of the two charges I have to find the electric field and potential at the point P. This is the point P. I need to find the electric field and potential at the point P because of the two charges. Now this point we are calling it as spherical system, which is given as r comma theta comma phi. R comma theta comma phi. And where what it is r, you tell me? R is a distance from point to this origin. This distance is called as a r. And so this angle which is called as a theta. This distance is a r. All of you. Now I need to find the electric field and potential at the point P because of the dipole. So I am joining the point P. I am joining the point P to this dipole positive charges. Now this distance I am calling this thing as a r1. This distance is a r. Next, this distance we have now, and this distance which I am calling this thing as a r2. All of you boliye. This distance is calling as a r2. Now I am finding the electric field because of the two charges. The electric field at this point P, which is caused by what I can say now here, electric field, which is given as electric field caused by the positive charge plus electric field caused by the negative charge. Electric field caused by the positive charge plus electric field caused by the negative charge. Where the point is there na, where the point is there, this point is a spherical system na. If it is not spherical system, you need to convert it to Cartesian system. Then what we can say, the distance from here, then what we can write, the distance you tell me now here. Then we should write the distance, which we should write if we have taken this point is x, y, z we have taken. So then what I should write, that this distance you tell me, the distance from this origin to this point P, which is called as what now, r na. So then you need to write this distance as square root of x square plus y square plus z square. You can write now. Now you tell me now which is simple to write now here. So instead of writing this whole thing, simply r is simple, or you want to write the square root of x square plus y square plus z square. So here if you feel it is comfortable, then you can write that one. Instead of writing this whole thing, I will simply write it as simply r. Right. Now you tell me now here. I want to find the electric field and potential at the point P. Now let us find the electric field now first. So here, which is given as electric field due to the positive charge, which is given as what we can say now, tell me. And that is kq by the distance is r1, kq by distance which is equal to r1. Here we are focusing on first magnitude, will focus, and we'll see the direction later. kq by r1 and plus what we can say, because of this negative charge, that we can say minus kq by r2. All of you tell me the total electric field, what we can write now here, kq we have taken common, then it will becomes 1 by r1 minus 1 by r2. Tell me this thing. So then what I can write, this electric field you tell me, which is given as, that is kq into what I will get now here, r2 minus r1 by r1 into r2. R2 minus R1 by R1 into R2. No, we are finding the, sorry, we are finding the potential, sorry, yeah. We are finding the potential. This is, we are doing potential, not electric field. V, potential I am finding, not electric field. Okay. We are finding the potential V, potential due to positive charge plus potential due to negative charge. We are finding the potential, not electric field. Fine. Now you tell me now what we can write now here. This is, so KQ into R2 minus R1 by R1 into R2. So now we are doing this thing. I am drawing one perpendicular line from this point to here. This I am calling as a perpendicular point. This is O. If I call this point is A and this point is B, and here this angle which is equal to 90 degrees. Here this angle is 90 degrees. So now you tell me now here. Now this, and it is right angle triangle now here. Since if you see carefully, this angle is theta, so this angle also will be a theta only in a parallel lines. These are distance between the two charges is very small. This compared to this OP distance. Now you tell me now, if I have taken this as, if I have taken this now here, this is theta. Now, so if you see carefully now, this is this distance BP distance and this AP distance. You tell me now AP distance, which we call this as, what you tell me, R2 I call now, and this BP distance we have taken it as, what you tell me now, which is equal to R1. This BP distance is R1 and this AP distance is R2. Is it fine, all of you? Now here, and this AP, which we can write this thing here, this total distance is AP. This I am splitting this thing as a OA plus OP, which I am splitting this thing as, this is OA plus OP. All of you tell me. This AP distance, the whole distance is split as a, so OA plus OP. Now you tell me now here, if you see carefully, I can consider this thing as a, this the BP distance, this distance and this OP distance. Can I say these two both are equal? BP distance and this distance both are equal, I can say now. So that means what we can write now here, you tell me. The BP distance, which is equal to BP distance, I can say this is my R2, which is given as, so this OA distance, this is some unknown, so this is my OA plus, can you tell me this OP distance, this distance, can I say this is same as this BP distance? Can I say this is same as BP distance, and which is given as R1? All of you tell me. So from this I can get this OA value, OA which is given as R2 minus R1, OA given as R2 minus R1. So that is nothing but OA here now. Now if this angle is theta, this is the 90, if I take this thing here cos theta, can you tell me cos theta kya hoga? So if I have taken a cos theta, tell me here, which is nothing but adjacent by hypotenuse, that is OA by D, I can say. This is the hypotenuse now, tell me all of you. So here this is my OA. Tell me now here. So from this I can get this OA value, OA which is given as D cos theta. OA which is given as, what I can say here, D cos theta. So now you tell me now here, this formula which I am modifying this thing as potential V, which is given as KQ, and this R2 minus R1, R2 minus R1 which I am calling this thing as a d cos theta, that is a OA. Now tell me, R2 minus R1 is a OA, that is nothing but d cos theta by, and you see this thing here. Here we have denominator, we have what we have to tell me now here, R1 and R2s. So this is a R1, this is a R2. If you observe carefully, and this R1 is a little smaller than R2 is a little greater than R. So here you see this thing here, R1 is a little smaller than R and R2 is a little greater than R. So the product of these two, what I am doing is, I am approximating this R1 into R2 product, I am approximating this to a R square. All of you, the product of these two, R1 into R2, I am approximating this thing as R square. So then see what happens now here, R1 into R2, I can say this as R square. Is it fine? All of you tell me. So the potential V, which is given as KQ d cos theta by R square. बोलिए. So finally हमको potential मिला, potential V which is given as KQ d cos theta by R square. Done everybody? Now, so here we have a dipole moment na? Dipole moment which is given as what? Dipole moment which is given as what we can say here, that is Q into D, charge into distance of separation na? So I can replace my V as what we can say now here, Kp. P is a dipole moment. P is a dipole moment into what we can say, cos theta by R square. This is my potential due to the dipole. Is it fine, all of you? This is the potential due to the electric dipole. Now, as we know, I know the potential from this, I want to get the electric field. We know the relationship between the electric field and potential. What is the relation now here? E is equal to minus del V. We have a relation now. What is that? E equal to minus del V. So del V, which is in what system? I have to write to del V, gradient in the. Here we have a parameter, R is there, theta is there. That means this is in the what system? Spherical system. Now tell me. So spherical system, how we can write the gradient operation? Tell me. In gradient operation of spherical system, which is given as minus, we have taken outside. Tell me what we can write. So here that is dou V by dou R into AR cap, 1 by R into dou V by dou theta into A theta plus 1 by R theta. 1 by R sin theta into dou V by dou phi into A phi. Tell me, all of you, this is a gradient operation in the spherical system. So now you tell me what we can do here. E, which is given as, now in this case I need to differentiate the potential with respect to R. If I differentiate with respect to R, only this is the variable parameters, remaining all are constant only. Derivative of this minus 1 by R square, what I will get, you tell me? 1 by R square, which is equal to minus 2, that is Kp, remaining terms are constant now here, cos theta by R cube I can write, and this is AR cap, plus 1 by R, we have a coefficient V is there, and what else you tell me now here? Now the derivative with respect to theta means that is only cos theta is a variable, remaining all are constant. So what I can write to tell me now here, that is because of this, which will get this as a negative sign will come now, minus cos theta, derivative is minus, okay, what I will get now here, that is kp sin theta by r square into a theta. Now if I differentiate phi, there is no phi term now independent of phi, so derivative will become constant, so it will become 0. So from this I will get my electric field as, take the common terms, minus will get cancelled, I can say this as kp by r cube taken outside, kp by r cube taken outside into, tell me what we can write, so which is given as 2 cos theta, 2 cos theta into ar cap plus sin theta into a theta cap. all of you बोलिए. So kp by r cube into 2 cos theta into ar plus sin theta into a theta. Done. This is my electric field due to the dipole. Need to be remember. Yes. And whatever the potential we have seen here, now you can see, now we have seen the potential V, which is given as kp cos theta by r square. This is the potential, and the electric field, which is given as kp by r cube into what we can say here, 2 into cos theta into ar plus sin theta into a theta. Done. Right. Now, so here is a dipole. If I say this is the negative charge and this is the positive charge, and the distance of separation between these two, the distance of separation between them, which is equal to d. Now we have a dipole moment, the dipole moment p, so which is always from where to where, you tell me, positive to negative directions. This is the direction of dipole moment. The dipole moment is always what direction? Positive to negative, like this. Now if we see carefully here, so here we have taken a point somewhere here. Now this point is A. How this point A to my dipole, you tell me? How this point A to my dipole, which is what direction here? Which is perpendicular to my axis of a dipole now. So this is perpendicular to my dipole. You see this thing carefully. Perpendicular to this my axis of the dipole. So then this direction, which is called as a broadside directions. If we have like this is called as a broadside. This direction, this is called as a broadside direction. Broadside direction means the point is perpendicular to the dipole axis, means dipole moment. The angle between the dipole moment and the point this point A, which is a 90 degrees. In broadside direction means how much we can say theta equal to 90 degrees. Broadside direction theta is how much here? Theta is 90. Now you tell me if the theta is 90, can you tell me the how much the potential will come? What is the potential if theta equal to 90? So cos 90, which will become 0 now. And we have the electric field. Tell me how much the electric field now here? Theta 90, cos 90, 0. We have only sin theta is there now. So which is given as Kp by R cube into sin theta. Sin 90 now here, it will becomes 1. So this is A theta. Isn't it, all of you? Kp by R cube. So this is the electric field and potential in what direction, you tell me? This is the broadside directions. This is broadside directions. Done. Next, if we have a point is here now, so this point B is there. Now how this point here, tell me now here? So here this point is along the dipole axis. The point B is along the dipole axis. This direction, which is called as a end fire directions. This is called as a end fire directions. Right. Now you tell me now here. Now let us talk about this electric field and potential in end fire direction. The end fire direction, tell me now here. What is your theta value? Tell me now here. Theta value 0 hoga na? Theta is the angle with the axis and the point B. So this angle is theta 0. If theta 0, tell me the electric field and potentials now here. So the potential V, which will becomes Kp by R square now. Kp by R square. And whatever the electric field, you tell me, which is given as 2 Kp by R cube into AR cap. This is the electric field and potential in case of what directions? Broadside and end fire directions. Is it fine, all of you? Next. Now let us do some observation here. Previously, when you have taken the single charge, we have observed what is the potential for the single charge, which is given as kq by r, and whatever the electric field, you tell me, which is given as kq by r square. अगर आपने ध्यान से देखा तो here this electric potential is proportional to 1 by r, electric field proportional to 1 by r square. For in case of a single charge we have seen. Now अभी हमने देखा dipole. Dipole means a pair of charges. In case of a dipole, you tell me now what is the potential for the dipole, you tell me. That is Kp cos theta by r square, and the electric field E, which is given as, tell me, Kp by r cube into 2 cos theta into AR plus sin theta into A theta. Now अगर आपने ध्यान से ऑब्जर्व किया तो now in case single charges, for the single charge the potential is proportional to 1 by r, 1 by distance. Electric field is proportional to what, you tell me? 1 by r square. Dipole means how many charges we have? Two charges. A pair of charges, not two charges we have. Dipole. In case of a dipole, you tell me now here how the potential is proportional to distance, you tell me? That is 1 by r square. Potential proportional to 1 by r square, and the electric field proportional to what, you tell me now here? 1 by r cube. All of you boliye. Potential proportional to 1 by r square, electric field proportional to 1 by r cube. Done. So this is, we have discussed for what charges now here? Dipole. Now let us consider, we have taken this thing as like a nth pole, if I say. Can you tell me how the scenario can happen? If I call this as something nth pole, if I say. Now how the potential proportional to distance, now tell me. How the potential proportional to distance in case of a nth pole, which proportional to 1 by r power n, I can say. That means n charges we have. And what about the electric field, you tell me? Which is proportional to 1 by r power n plus 1. Check it, all of you. It's proportional to 1 by r power n plus 1. Isn't it, everybody, tell me? So in this manner we can able to, this is the relations, right? All these are the PYQs. Whatever we are discussing, wherever we are writing the highlighted points, notes, those are the PYQs only, remember. Chalo? Right. Let's see the next one. Electric dipole in an uniform electric field. What will happen if I place my dipole in a uniform electric field? Okay. Let us see this thing here. Consider we have the electric field is like this. We are calling the electric field is a uniform electric field. We are talking the electric field is what, you tell me now? Uniform. Electric field is this directions. Consider in this electric field, let us say we have a dipole is placed. We have a dipole is present here. Dipole means pair of charges, now positive charge, and here we have a negative charge. Positive charge and negative charge we have. Right. Now you see this thing here. If I place a dipole like this, now see what's happened now here. Because of this electric field, this positive charge will experience a force. So, and so what is the direction of the force on this positive charge, you tell me? What is the direction of force on the positive charge? Along the direction of electric field. Yes or no here? This is the direction of force now here. So this is the force acting on the charges. This is a force acting on this charge. Now tell me now here, and because of this negative charge we have force is like this. Now tell me, because of this negative charge the force is like this. Now tell me now here, and if you see carefully, and we have a two forces, one force, both magnitudes equal, you tell me, this magnitude of force both are equal, isn't it? Both are equal, and so then as a result the forces will get cancelled now here, and these two forces along the same line, you tell me, these two forces are acting along the same line. If the two forces of equal in magnitude opposite directions, they will cancel each other. So as a result the net force acting on this system, which is equal to what we can say, 0. The net force acting on the dipole is how much, you tell me? 0. Fine. So here it is, fine thing here. Now let us consider some other scenario, some other case. Let us consider we have the electric field is like this. We have the electric field is like this, uniform electric field only. In this, now what I did, you know, here, now earlier we have placed my dipole which is exactly parallel to this my electric field. Now here I am assuming this my dipole which is placed like this. My dipole is placed like this. Now here this is my positive charge and this is my negative charge. Positive charge and this is my negative charge. That means, and what is the direction of the dipole moment, tell me? The direction of dipole moment is from where to where now here, negative to positive charge now, like this. The direction of this negative to positive. Now you see this thing here, this is my dipole moment, and on this one here, see the direction of electric field, you tell me. The direction of electric field is like this. Now tell me, this is the direction of electric field, and now there is an angle between these two. Now tell me, there is some angle between the dipole moment and the electric field. You see carefully. Now can I resolve this dipole moment now here? Now can you talk about the forces acting on the charges, you tell me? The force acting on this positive charge which is like this now here, which is QE, and the force acting on this charge which is opposite direction now here, that is, so this force which is equal to QE, isn't it? All of you tell me. Now if we observe this thing here, now this force acting this direction and this force acting this direction, and here these two forces are not along the same line of action, but the two forces earlier, these two forces are same line now, that's why those two will get cancel each other. But these two forces we have not acting, this force acting along this line, this force acting along this line. As a result, what happens now, it will constitute a couple, it will constitute a couple. Hana boliye. So two forces of equal in magnitude and which are not acting along the same line of action will constitute a couple na? Will constitute a couple. Because of that we have a torque will be produced in na? So we have a torque we have. So tell me the torque which is given as what we can say, force into perpendicular distance. What the torque is given as, what you tell me? Torque acting on this. Here in this case there is no torque. In this case there is no torque, but here we have torque is there now here. In this case we have torque is there. What the torque is given as, what we can say here? That is force into perpendicular distance between the line of action of forces. Force into perpendicular distance. Perpendicular distance. between line of action. Line of action. Line of action of forces. Right. Tell me now here. What is the perpendicular distance? You see this thing here. Now here this force acting here. This is the force. Now this is, I can call the perpendicular distance. I can call now. This is called as a perpendicular distance, and this angle is theta. So and this is the d here, distance of separation, and this will becomes what you tell me, which is equal to d sine theta, and which is given as d sine theta. All of you now tell me. So the torque which is given as force acting, which is nothing but QE into perpendicular distance, and which is given as d sine theta, which is given as d sine theta. Okay, QE d sine theta. Is it fine, all of you? Now, so this torque which will be given as, which is given as we know, Q into E, which is nothing but dipole moment. Q into E, which is nothing but dipole moment. Dipole moment, and which is equal to PE into sine theta. And this thing which I am modifying this thing as, which is equal to dipole moment, is a scalar form magnitude, which I am writing in the vector form as, which I can say this as P cross E, which I am writing in the vector form as, you tell me, tau is equal to P cross E. This is the torque acting on a dipole. This is the torque acting on a dipole. Okay. Done? Fine, all of you? Everybody. Done. Yes. Fine, I think so. Here something here, the pen is not, it is coming, the dots are visible more. I don't know, here it is not working properly today, and we'll see this thing here. Okay. Okay, that's why here, and we are closing the session for with this, and tomorrow we'll continue the remaining topics. Tomorrow we'll see the remaining. Tomorrow we'll talk about the method of images, and we'll talk about the polarization in the dielectrics. And tomorrow we are going to discuss about the capacitance mechanism also, we'll see. Fine. So in the capacitor we have a, we used to call a transient state, steady state we used to call. What is a transient state, what is steady state, in detail we are going to discuss. As I told, so you do follow me in the WhatsApp and Telegram. So here, and so here in the WhatsApp you can give, you can share, you can send me the your WhatsApp me here in this number 93980214119, right? And you can follow me in the Telegram channel. You can search my BV Reddy GATE in the Telegram app. Right. Fine. So that's for the today's class, and we'll meet tomorrow. See you. Bye bye. Okay then. See you. Bye bye. Good night.